In this video, I will be discussing the principles of carbon dating. Carbon dating is a method used by scientists to identify how old a sample is. So, for example, if a skeleton is found in an archaeological discovery from many years ago, scientists can look at the carbon located in the skeleton and work out how old the sample is. This is because carbon is taken in to plants and animals. This is shown in this process here. So, carbon exists in the atmosphere as carbon dioxide, shown here. This carbon dioxide is then taken into plants in the process of photosynthesis and stored as sugars. Humans then eat these plants and the carbon becomes incorporated into them. Now, when humans die, no more carbon can be absorbed. This is important because it means the carbon cannot be replenished. There are two forms of carbon in the atmosphere, and I'll now go on to this. So you have carbon-12, seen here, and carbon-14, seen here. Carbon-12 and carbon-14 are both incorporated into carbon dioxide. The difference between carbon-12 and carbon-14 can only be seen at the atomic level. So carbon, like all atoms, has a nucleus. And this nucleus is made up of protons, seen in red, and neutrons, seen in blue. Carbon-12 has 6 protons and 6 neutrons. Whereas carbon-14 has 6 protons also, but now it has 8 neutrons. There's an extra 2 neutrons located here and here. This is important because the extra 2 neutrons mean this type of carbon is far more likely to decay and does so at a much faster rate than carbon-12. Carbon-12 remains fairly constant. The decay of carbon-14 is known. This is called a half-life. A half-life means that there is a consistent time for the sample taken to decay by half. In the case of carbon-14, it's 5,730 years. As no more carbon-14 can be absorbed into the sample, if you compare the amount of carbon-14 in the sample and that in the atmosphere today, you can work out how old it is. This is shown here. So if we have a sample here with X amount of carbon in it, carbon-14 in it, and as we compare it to today's level, if we work out the difference in levels and relate it to the time taken to divide by half, we can work out how old the sample is. So let's take a look at this scenario. So we can consider today's level to be 100% or 1, as it's shown here. And if we had a sample with half the amount of carbon-14 in it than today's atmospheric level, we can work out that it takes 5,730 years for this to happen. Therefore, the sample is 5,730 years old because half the amount of carbon-14 remains.